When I take stock of the three most significant events of my life, here's what I see. The birth of my two girls, of course, getting married, and seeing plate 11 in Andre Roubo's 18th century masterwork on woodworking. Now, you might think that I'm exaggerating here, but I'm not. This engraving from Roubo absolutely transfixed me because this drawing solved all of the problems that I was having with my workbench at the time. Roubo's workbench was simpler and stouter than any bench I'd ever built or even seen, and it could handle every major woodworking and work-holding operation I could throw at it. So for the last 5 years, I've worked exclusively on a Roubo-style workbench, and that bench has taught me a lot about work-holding and woodworking in general. And now I want to share with you this incredible bench and how it would have been built in the 18th century using only hand tools and muscle. Now, if you want to use power tools to build this bench, you have my approval. After all, the bench doesn't care about the tools that created it. It only exists to make our lives easier. To sum up my philosophy of workbench building, here are the most important points. A bench should be able to hold work so you can work on a board's faces, edges, and ends. It sounds simple, but it's not. Most modern workbenches fail on 2 out of 3 of these requirements. First, to work on faces you need a flat bench top and at least one planing stop. An end vise, as shown here, is optional, but man, I sure like to have it. Second, to work on edges, you need this front face of the leg to be in the same plane as the front edge of the bench top. This allows you to easily work on the edges of long boards, panels, and doors. It sounds simple, but this detail will absolutely transform the way you work. And finally, you need to be able to work on the ends of boards. There are a variety of ways to do this. Most involve a face vise, such as this simple but stout leg vise. No matter what vices you choose, make sure they match your requirements. Though Roubo drew this workbench before the revolutions in France and the United States, this bench is nothing short of revolutionary for the modern woodworker. It is simple, like the idea of equality, and it is easy to construct, unlike a true democracy. But like an egalitarian society, it is robust and it is difficult to ignore. And finally, it gives you the liberty to do any kind of work. One of the questions a lot of woodworkers have is, how do you build a workbench if you don't have a workbench? Well, it's pretty easy. You start by building the top on sawhorses, which is what we did here. Now, when I built the top, we began with 2 really thick slabs of cherry that were about 5 inches thick and about 6 feet long. In the rough, I edge jointed them together and glued up one big slab, and then with a hand plane, I dressed the top and the undersides flat, and then the edges. After that, it was obvious there was a lot of checking in here all through the boards during the drying process, and so I filled it with an elastic epoxy that is designed for stuff like this, that moves with the wood. Now, to make it look like it fit in with the cherry, we colored the epoxy with some iron oxide powder, and I really like the result. It looks like mineral streaks that you would find in cherry. After that, I added a quick release vise here at the end and a series of dog holes along the front edge of the bench. And now I can build the rest of the bench, the underside, here on this top. So let's take each one of these steps in turn and see how we put this top together. When I started on this project, I was hoping to find one massive slab of wood for the top, just like the top shown in Roubo's 18th century book, L'Art du Menuisier. After a lot of searching, I was able to get some cherry that was thick enough and wide enough to make a top with one glue line down the middle. It was close enough. Now, edge joining a monster like this might seem difficult, but it's actually fairly easy. You just have to treat the edge of the board like you would a board's face. Get it flat and true, and check your work with a straight edge. When you're close, balance the two slabs on top of one another and check your work. Try to rotate the top board a bit. If it rotates easily, you have a bump in the middle of one of your edges. If the top board drags at the corners, then you are real close to getting a good joint. Glue up is just like any major operation. I used a slow setting hide glue, lots of clamps, and some help from my coworkers, especially when my first glue bottle ran dry. After the glue dries overnight, at least, you can trim up the top to size. That's because you don't want to have to plane any more wood than necessary. Ripping the top pieces to width was the one place where I cheated, and that's because my handsaws were just too slow. And so I turned to our shop's bandsaw. Sorry, Monsieur Roubo. Now, in the 18th and 19th centuries, these slabs probably would have been ripped at the mill using either water power or even steam powered. Well, at least that's the way I rationalize it. Then I dressed the edges with jack and joiner planes and trimmed the ends with a crosscut handsaw. Unlike when ripping, the cross-cutting is fairly easy work. Now, because we're going to build our bench without a bench, you need to get this slab as flat as possible at this point. That's because you're going to do all the joinery for the bench right on this top. To get the top close to flat, use your jack plane with its iron sharpened to a curve. Work across the grain, which will allow you to take a fairly heavy bite. When you have cleaned off all the fur from one face, start to use your winding sticks to look for twist and for high spots. Work any glaring high spots down with your jack plane. When you get it as flat as you can manage with that tool, it's time to switch to the joiner plane. Begin by planing diagonally across the bench top, first angled one way, and then angled the other way as you move down the length of your top. And when you can remove material from every part of the bench top with your jointer plane, then you can switch to planing with the grain with your jointer plane. I'll also reduce my cutting depth at this point. It's harder to plane with the grain than it is diagonally or directly across it. Once the joiner plane says the top is flat, then you can start work on the other face of your bench top.
Now I have some gaps in the bench top. You may not have these gaps that I want to fill with some epoxy. And I'm going to tint this epoxy a little bit so it looks like mineral streaks in cherry. Now you can buy epoxy tint, but I just went down to the art store and bought some of this Mars Black, which is a synthetic iron oxide. And all it takes is just a tiny little bit, even less than that actually. And then when you stir the epoxy in, to the pigment, it turns completely black and it dries jet black. And this epoxy is different than other epoxies in that it's designed to be flexible with the wood. So it will move and shrink and swell with the seasons, just like the bench top.
Now, don't be afraid about planing epoxy because you're not going to ruin the tool. You can sharpen it, can't you? Before you can cut your joints, you have to have some way to hold your parts. I installed a quick release vise in the end vise position of my bench, and I lined it up with a row of dog holes that I bored through the top. A bit and brace is a great tool for this job. You can get a lot of torque. I'm using a brace with an 8-inch sweep here. You'll have an easier time if you have a 10-inch or 12-inch sweep brace. By positioning the holes near the front edge of the bench top, I'll be able to work narrow boards with planes that have large fences, such as a plow plane or some molding planes. Well, now it's time to cut the joints in the legs that join the legs to the bench top. Now, Roubo called out a very unique joint for this. It's a sliding dovetail and a very large tenon. But we don't know why Roubo called for this joint, but I have some guesses, and here they are. Now, the primary strength of this bench is the way that the legs are joined to the top. And so you need a lot of meat. You need a lot of penetration on this leg into the top. And normally with a leg this size, that would call for a double tenon. But a double tenon means a double mortise. And a double mortise is a lot of work. It's a lot of boring. It's a lot of bashing. If we use a single tenon and a dovetail, it's a lot less work. We only have to cut one mortise in the top, and then we can saw out the cavity for the sliding dovetail. And the dovetail shape keeps this front part from warping out. Now, how are we going to make this joint? Well, this is a pretty deep joint. We have about 5 inches of meat here that we have to cut away. So your traditional tenon saw, it's just not going to make it all the way to the bottom of the joint. So we're going to have to switch to a full-size rip saw. We need a big saw to get all the way to the bottom of this big joint. And then to bash out this waste between the tenon and the mortise, we're going to need a really big mortise chisel and one of my favorite tools, this enormously huge honkin' hammer. So let's get started. My legs are 6x6 timbers that I found at the home center. I think they were a batch of lumber that escaped pressure treating. In any case, they needed to be cut to length before I could dress them. Cross-cutting thick stock accurately is a special challenge. Your saw will want to wander through the thickness of your work. Here's how to deal with that. Knife in your cut line all around the leg. Start sawing on one corner and work your way along 2 cut lines. Then rotate the stock 90 degrees and saw along the new knife line, using the already created kerf as a guide for your saw plate. Continue to rotate the work 90 degrees until you have cut all the way around the leg. If there's any material left in the middle, a few good strokes with your saw should separate the waste. Then dress the ends of the legs with a block plane. If the wood is difficult to cut, you can moisten it with some paint thinner or alcohol. Lay out your joints using the drawings provided on this DVD and mark them with a knife. To cut the joints, you probably are going to need 2 rip saws for the cheeks, a tenon saw to get the joint started, and a full-size rip saw to finish the cut. This cut is too deep for just a typical tenon saw. Start sawing the tenon cheeks by working on one corner, advancing on 2 lines simultaneously. This improves your accuracy. When you reach your tenon's baseline and the far corner, turn the joint around and saw the other side of the cheek, using the previously made kerf to guide your saw. And remove the waste in the middle. Go as deep as you can with your tenon saw, then switch to the rip saw. After you've cut the 3 cheeks, you can then work on the dovetails. Again, this is a job for 2 rip saws, and it requires great care because this is a difficult surface to correct if you go awry. Start on a corner, and with your tenon saw diagonally, advancing on 2 lines, just like you did with the tenon cheeks. When you reach the baseline, move to the other side of the dovetail and saw down the other line, working diagonally again. Then finish the cutoff with your rip saw. To remove the waste on the inside face of the leg and the dovetails, use a carcass saw or a sash saw that is filed for a crosscut. To make the cuts easier, I deepen my baseline by driving a wide chisel into it. Then I pare out a triangular bit of waste right at the baseline, creating a trench for my saw to ride in. Then it's just a matter of holding the saw plumb and sawing the shoulder and the dovetail waste away. The waste between the tenon and the dovetail can be removed in a couple ways. You could saw out most of the waste and clean up things with a paring chisel. Or you can bash it out with a mortise chisel. I chose the mortise chisel. Drive the tool straight down near, but not on, your baseline. Drive as deep as you can go. Then chisel out a triangular bit of waste by driving down at an angle. This is just like removing waste between dovetails. Then drive straight down again, deeper and deeper, and then at an angle again, deeper and deeper. Repeat this process until you get halfway through the leg. Flip the leg over and work the other side the same way. Eventually, you will be able to pry out the waste. Then you just have to clean up the floor of the joint with a paring chisel. Now we're to the point where we need to cut the sliding dovetail and the mortise in the top that's going to hold the leg. Now, in cabinet work, when you cut a mortise, you usually pick a chisel that is equal to the width of your mortise. So if you're going to do a 1/2 inch wide mortise, you'd pick a 1/2 inch wide chisel. Now, the problem with this joint is that we need to do something more of a timber frame approach. And the reason is because this mortise is 1.5 inches wide. I don't have 1.5 inches wide mortise chisel, nor do I really want one. So the timber frame approach is to first take your brace and bit and bore out as much of the waste as possible. And then follow that up with a mortise chisel and chop halfway through on this side, and then flip the top and repeat, boring and then chopping. And then you come back and pare the walls to split the wood off of the walls, which makes it much easier than just merely chopping. Now on the dovetail, it's a little simpler. What we're going to do is we're going to first saw out the 2 extents of the dovetail joint. Then we're going to take a mortise chisel and chop out the waste between, and then smooth the floor of it with a router plane. Now, what's different about this joint than with timber framing is that with timber framing, this joint would be rather loose because we have a lot of joints in the house that can really hold everything together. But Roubo is very specific about this joint. He says it needs to be tight, and so we're going to use cabinet making principles to make this as accurate as possible. The less measuring you do here, the better. Every leg is different. So place your legs on your upside down bench top exactly where you want them and trace around the joints. Then just remember to work inside of your pencil lines and you'll be okay. Then you want to transfer the layout of each joint to the top surface of your bench top. You do have to do a little measuring here, so take your time. When making furniture, it's usually best to just chisel out a mortise. But when you get into joints of this scale, I find it best to bore out a lot of the waste, then follow that up with a chisel. As with any joint that passes entirely through the work, it's best to work from both faces and meet in the middle. So starting from the underside, bore halfway through the top using the biggest bit that you can swing. Then chisel out the waste. Align the edge of the chisel with the grain to split the waste off the walls. Watch the grain direction to control the split. At the ends of the mortise, align the edge of the tool across the grain to work your way up to your layout line. When one side of the mortise is complete, flip the top over and repeat the entire process. Bore halfway through and chisel out the rest. When the joint is complete, clean up the walls with a paring chisel or a rasp and check your work with a square. Lucky for you, the dovetails are easier. Knife in the joint on the front and back edges of the bench top, if you haven't already. Then deepen the knife line with a chisel and pare out a small triangular piece of waste to create a trench for your saw blade, just like you did on the shoulders for the legs. Then saw out the angled walls of the dovetail socket. This is a lot like sawing out a tenon. Work diagonally along two lines until you hit your baseline. Then move to the other side of the joint and saw down to the baseline on that side. To remove the waste, first make a few relief curves in the waste area with a crosscut handsaw. 3 will do the trick. Then it's simple work to split most of the waste away with a chisel and a mallet. Stay about 1/8 to 1/16 away from the baseline and watch the grain direction so you don't split the wood below your baseline. To finish the joint, use a router plane. By taking a few small bites, you can finish the floor of most of the dovetail socket. Then, when you have worked up to your baseline, switch to a paring chisel to clean up the inside acute corners of the socket that the router plane couldn't reach. Use the flat side of the chisel against the floor of the socket to guide the cut. Then it's time to dry fit the leg. Put a piece of waste on the end of the leg and pound the leg in. You want the leg tight against the face cheeks of the tenons. The edge cheeks aren't as critical. Those will be wedged up during the final assembly. This whole process might take some fussing and fitting, but take your time and go for a good fit. This joint is where the bench gets most of its strength. Probably the trickiest part of the entire project is assembly. And that's because the whole workbench has to come together at one time. We can't assemble the sides individually, put them in, and then get the long stretchers in. Everything's got to go together at once. That means things are, a little bit tricky. We have to have everything fit so it can slide together with the glue on it. We have to get all the mortise and tenon joints fitting together nicely so then we can draw bore them with these oak pegs to pull everything tight. We also have to make sure that we have all the holes cut in the front left leg for the leg vise. This is the hole for the vise screw, and this is the hole for the parallel guide. Then, once everything is together, we're going to cut some wedges out of oak and wedge these mortise and tenon joints here up in the top, just like Roubo told us to do. So let's get started. Once again, measuring is the enemy here. To get your stretchers all on the same plane, cut 2 scrap boards that are the exact length of the distance between the bench top and the stretchers. Clamp these scraps to your legs and rest your stretcher against the legs. The scraps act like a shelf. Now you can knife in exactly where the shoulder for the stretcher should be. This technique works well when your legs are slightly angled. It's a real hazard with handwork. Each stretcher is made from 2 pieces. The outside part is the shoulder of the tenon that you just marked. The inside piece of the stretcher is the actual tenon that is sunk into the leg. So saw the outside part to length, following the lines that you just marked on your stretchers. With the front piece cut to length, confirm that it fits between the legs, and then glue it to the rear piece of the stretcher. This piece can be overlong, so you don't have to worry about gluing the front piece on in an exact location. After it's clamped up, let the stretchers dry at least overnight. Now you can lay out bore and chisel all the mortises in the legs. These are blind mortises that meet in the middle of each leg. For the first mortise on any leg, cut them 1.5 inches short. Then join the two mortises when you make the second mortise. This technique prevents you from splintering out the inside corner of the mortise, which makes for a stronger joint. Then you can miter the ends of the tenons on your stretchers. Now, you're not trying to get the two mitered ends to meet inside the leg. That means you can cut one of the tenons a shade short. Show each tenon to its mortise so you can mark off where its edge cheeks should be. Then saw the edge shoulder using a carcass saw filed for crosscut, and saw the edge cheek with a tenon saw. Fit each tenon to its mortise, and then prepare the joints for draw boring. Draw boring is where a hole in the tenon is slightly offset from a hole in the mortise. When you drive a peg through the two holes, it tightens up the joint. Now, this is a great technique if you don't have a lot of clamps, are working without glue, or have some green wood that might shrink a bit after assembly. Now, the first step is to drill a 3/8 inch diameter hole through the disassembled mortise and the entire leg. Now, center this hole right where the tenon would go and make it about 1 inch in from the edge of your leg. Then assemble the joint and mark the location of this hole on the tenon. Use the center point of your 3/8 inch bit to make this mark. Disassemble the joint and drill a 3/8 inch hole through the tenon that's about 3/32 closer to the shoulder than the mark you just made. That 3/32 offset will pull everything together when you drive the peg through. Before you glue and peg everything together, you should add the equipment and the joints you need for a leg vise, if you're adding a leg vise. We're real close now, and we only need to do 2 more things before we can really start to call this a workbench. The first thing is the face vise. Now, in the face vise position, I've installed a leg vise. And I really like leg vises because you can customize them to do whatever you want them to do, in size especially. And they're pretty cheap. Now, you make your own chop. This is out of hard maple. And I've used a commercial screw here, commercial wooden screw. You can also use a commercial metal screw, which will cost you only about 30 or 40 bucks at most. The other features of the leg vise that are important to know is this one has a metal garter, and the brass garter is what joins the chop to the screw, so the whole unit moves in and out together and still allows it to move. The other feature of a leg vise is a parallel guide, which is this stout piece of 1/2 inch maple that is through tenoned into the chop. When you move this metal peg to the different holes, then it allows the top of your chop to pivot in and out and grab different thicknesses of work. It's very simple, very ingenious, and it holds like crazy. And the last thing we have to do before we can really call this a workbench is do a final flattening of the workbench's top. And we're going to do that with a foreplane that will remove any high spots. Then we're going to follow that up with a joiner plane for the final truing, and if we want to make it look really nice, a smoothing plane. Leg vises have 2 key parts that involve the leg: a hole for the vise screw and a mortise for the parallel guide. For the vise screw, I made a square mortise through the leg. Then I notched out the rear of the leg to accept the vise's threaded block. To make the square mortise, bore out most of the waste, then clean up your work with a chisel. To make the notch on the back of the leg, saw out the walls of the notch, pop the waste out with a chisel, and clean it up with a router plane. This should seem very familiar. The mortise through the leg holds the parallel guide, which is attached to the vice's chop. This through mortise should be slightly wider than the thickness of your parallel guide. Bore halfway through the leg and clean up your mortise with a chisel. Flip the leg over. Bore halfway through and, again, clean up the cuts with a chisel. Fare the walls of the mortise with a wide paring chisel. Now you can add glue to all the joinery surfaces. I used a slow setting epoxy with a couple hours of open time. Knock everything together and drive pegs through your drawbores. Wedge the tenons that protrude through the top. I used a 4-degree wedge made from oak. I sawed these out by hand. Once you wedge each tenon, let the glue dry, and then you can flush up all the joints with a saw. To make the hole in the chop for the vice's screw, drill a series of holes around the perimeter of the hole that you planned, and then knock out that center waste. All this junk will be covered by the brass garter, which ties the screw and the chop together. Saw the chop to shape. I ripped the straight edges with a rip saw, and then sawed the curves. The parallel guide is 1/2 inch thick maple, with a variety of holes bored into it. The holes hold a metal peg. When the peg contacts the leg of the bench, it pivots the jaw against the bench, grabbing your work. The parallel guide is secured to the chop using a wedged through mortise and tenon joint. This is all stuff you've done before, so it should be a cakewalk. The top really should be fairly flat here, but I still had this big hump in the middle. So I used my jack plane to knock down the middle by planing across the grain. Then I checked my work with winding sticks and worked down a nasty high spot at one end of the bench top. When the winding sticks said everything was flat, I used a joiner plane to finish the flattening. Diagonal strokes help prevent you from putting a bulge back into the top. Now there's a reason the workbench is wet. It's a good idea to use paint thinner or alcohol on the end grain of the legs to soften them up. This makes the planing easier. And finally, I dressed the top up a bit with a smoothing plane. There were still some areas of tear out remaining at the end, however. But remember, this is a workbench, and you'll remove that tear out the next time you flatten the top. People get really worked up about workbench finishes. They've got all these crazy formulas that involve the cheese grater and beeswax and a double boiler, but I like to keep it really simple. And this is an effective workbench finish. In fact, a finish that we use on almost all our shop implements that you can make using basic shop chemicals. Now there are 3 parts to it. There is a little bit of varnish. It's 1/3 varnish. It can be any varnish. Polyurethane is a varnish. It can be, spar varnish, whatever you have on hand. It's going to be a little bit of linseed oil, 1/3 linseed oil, and it's going to be paint thinner. I like to use the odorless stuff just to keep the odor down. Now the varnish gives you a little bit of film, not a lot of film, but just enough film to protect your bench from, spills. The oil is a little bit of water repellent to allow you to flick glue off of your workbench because, water-based glues will sometimes get on your workbench. And the paint thinner just makes it easier to apply. So all we do is take a salsa jar, and you can mix this up pretty much as you need it. So that's 1/3 varnish, 1/3 boiled linseed oil, which is running a little thick and snotty. And because of that, we need a little bit of the paint thinner.
Fill that up. Then we're going to get a lid, shake it up, and it's okay if there are some bubbles in it, and then rag it on. A couple coats of that, and you'll be good until you need to flatten your workbench the next time, and then apply it again. And that's all there is to it. Now the shelf on this workbench is definitely optional, but it was original equipment on the 18th century workbench that Roubo drew. And it's a really handy place to keep your bench planes and other tools as you're working. Now the way we are going to install this shelf is we're going to take small 1x1 cleats and nail them to the insides of the stretchers. And then we're going to take pine boards and cut half lap on both edges, and we'll maybe cut a little bead if we want a little decorative detail, and then we're going to nail them to the cleats on the inside. Now, when you do nail these, you only want to put one nail in the middle of each board, and that's so that when the boards expand across their width, they won't crack. It's real simple, real easy, and so let's get it done. Begin building the shelf by taking some 1x1 sticks and cross-cutting 4 cleats, 2 short and 2 long, to attach to the inside of the stretchers. I'll get things close with my miter box saw here and then shoot the cleats to their final length. Attach the cleats with glue and nails. Now I'm using cut nails here, so I need to drill pilot holes to prevent the nails from splitting the work. With the cleats attached, I can then work on the boards for the shelf. The boards at each end need to be notched at the corners so they'll fit around the legs. Once those are fit, then I used my plow plane to shiplap the long edges of the boards. You can add a bead at the edge if you like. I did, and then nail the shelves to the cleats. One nail centered on the end of each board. That concludes the basic bench as shown in André Roubo's 18th century treatise on woodworking. But I still have a lot more that I want to add to this bench. I want to put a chisel rack here on the back edge, which is a traditional French touch. I also want to put a lid over the tool well down below, and I have some other work holding that I'm going to add. But that's the beauty of this design. It is so open-ended that it will evolve as your woodworking plans germinate. And that open-endedness is what makes this workbench design truly revolutionary.